into the, so either you can save it into Notepad or you can actually save it into the Excel here. Now on this one, PDF, you won't be able to save on, like the one on Excel here, you can do that. You know, once you completed your program, just like, okay, let me see. So if you have completed your program like this, and then you wanted, let me see, enable editing. Okay, enable editing, and then you want to do, so you want to do just open up another Excel sheet, and then you want to do just change this one and just put C++. So that way when I open up this Excel and then I look at here, I would see the program just like here's what I do for this is for Tech 2, as you can see. For Tech 2, that's what I do. So when I save, this one was the DLab 1, and then when I when you completed all this information and you do your program on your program on Visual Studio, and then after that you copy it and you paste it right here, called the one under the sheet said test program, paste it here, and then upload this. Look like the one that look like for Mr. Smith, he uploaded his assignment. I cannot now Kumi, the same thing. Yeah, the one that you put in here, it's put C++. I cannot open that up, as you can see, right? This one right here, DLab 2 C++. I cannot open that up. Do not use that. Just put either DLab 2 SP2022, so that way I know it's DLab for like here, see DLab fall 2020. Now this one for Tech 2, put DLab 02 SP 2022, so that way I can identify it quickly, because it's harder to get, because you have from previous semester. So make sure you want to put DLab 01 SP 2022, so that way I know it's applied to this semester. Okay. Same thing with Tech 1 too. Also to do that to make sure that when you upload your when you upload your e-calculation, make sure you put SP 2022, so that way I know that is supposed to be for 2022 semester. Like I said, hold on.
Just real quick.
Hold on. Let me go ahead and go through this quickly, and then I'll answer your question. One moment. Okay. Okay, so let me see, Joe. Like I said, you uploaded, now you upload an SLN file, and I cannot open that. So we got DLab 2. DLab 2 right here, DLab 1, and it's an SLN. So if I click on that, I cannot open up that file. I can only open with the one.cpp. Okay.
Or text, right?
Excuse me.
Or text.
Or text. You can do like right here, like you did on the DLab 2 here, and you save it as a I believe you save it as text file, one of these. So here's from 2022, you save it as text file. So I can open up that, and I can, you know, be able to run the program. Right now, this is so this is what I have for student for Tech 2 for that was uploaded that I was able to run. So therefore for these are the students that uploaded. So like I said, Kumi, I cannot open up year 2, so I cannot check. Joseph Smith, I cannot open up your number 1, so I cannot check. But the one for Kumi, number 1, I was able to open up your software and run it, and look like your software is good. So you can go ahead and build your board. And same thing with David Foster. I know that David already did this. He built his board and was able to pass in the classroom. And same thing with Lou. I saw that. I know Joe was able to build and then run his program and was passed also on 1. But like I said, I cannot run the software that you uploaded onto the website. Okay.
I'll resend it to you.
Okay, thank you. Yeah, just make sure you do that.
Thank you.
You're welcome. Okay, like I said, so make sure that when you save at now this is for Tech 2. The same thing. This is applied for Tech 1 too. You can put like you can say you can go to save as, and then you put calculation 01 SP 2022 for your first calculation, and then either NPN, PNP, and dot text, and so that way I know when I look at that, and I know that it's applied to the spring semester and whatever the program for calculation is, and then I can give you credit. And make sure you save it in the notepad, and I can do that. Or you can paste it, your code onto the Excel and upload the Excel. So that way I have your schematic and also your program there. So that way I know that applied there. Okay, so that would be make it easier for me. Because there's a lot of students, it's harder when you have so many students with all the from previous semester. Okay, so so any other question for anyone? But for Tech 1, you know, look like everyone has been keeping up with the pace. So for Tech 1, I know that you guys have to work on for the lab vault in the classroom, but when we uploaded the assignment for D-Lab, you need to focus on working on the D-Lab, get that completed. Once you get completed that, and then you jump back onto work on the lab vault. Okay, so this is more essential right here. The D-Lab 1, D-Lab 2, we need you to get on it because each one of these projects, it's going to take, now we're getting pretty short in semester. So each board, so each lab would require, you have to complete it within 1 week. Okay, so this one here is already uploaded, so this is coming this week. So by Friday, so this thing need to work, and it will be, everything need to be turned in by Friday, so that way I can give you a feedback, and so you can you can start your building your board probably by Monday or something, and so that way you can go and take it, and then you can go to the lab and be able to run it for the instructor to verify so he can give you a credit for completion for your coding and for your building your hardware. Okay, so that's pretty much it. So like I said, each one every week.
How do you expect Tech 1 to do the D labs?
No, Tech 1 does not apply to the Tech 1. Do not do. This is only applied to Tech 2 student.
Gotcha.
Tech 1 only require is to do the Tech 1 assignment, which is here. Okay, I know they had to do some of the e-program, and so and there's a sample program on the website in the handout, so you can always use the handout. For Tech 1, you can use the handout here called the sample program right here, and this one can use as your template for writing your coding. Now you can do this one and do this, so do this bipolar one first, practice that before you attempt to do the one on the assignment from the classroom, which is these here. Okay, all right, so any other question? Okay, look like everyone that's clear. Okay, back to you, Mr. Pham. Like I said, we do have the board in the classroom, so let me so drop by the classroom if you want to buy the board. It's $27, and I have those available in the classroom. We open Tuesday through Thursday from 3 p.m. till 7 p.m. Okay, just come in the classroom, then just come and see me, and I can. And then you can purchase those board, okay? And then I can lend you the tools necessary to build your test board, okay? Okay, back to you, Mr. Pham. Thank you.
Sorry, Sam.
Yeah, go ahead, Louis.
Hey, for that board, is that for us to for Tech 1 or just for Tech 2?
That is only for Tech 2. That's only for Tech 2 student. We're not building any board right now. You're just doing, your assignment is this here.
Okay, thank you.
You're welcome. Okay, back to you,
Hey
Mr.
Sam,
Pham.
hey Sam, real quick. So if we have a little bit of time, like we discussed on the email,
Yes.
if you okay, cool. Just
Yeah, I can work with you after the lecture today. So.
all right, cool. Thank you.
Okay, you're welcome. Okay, back to you. Thank you, Mr. Pham. Okay.
Okay. Hello, everyone. First thing, you can get any question to me. No? Okay, so you can see we get one more week next week, then we get another week off for spring break. Okay, that means after next week, then you will be off for 1 week. Okay, so not much time. If you have to do the lab, you have to quickly do it. Okay, for any student in TechCube, you want to complete the program in this semester, have to be hurry up. Okay, so let me turn it into my iPad. Okay, last time we already talking about the AC circuitry for the bipolar transistor. Okay, again, for more understanding, okay, and you have to remember, if you want to doing for amplifier analysis, first thing you have to complete any DC calculation. Second thing, you didn't see any capacitor in our AC circuitry. They will be shorted. And also you cannot see any DC power supply in the AC, the thing that they shorted around. And if you go detail, you can use either pi module or T module, and you get a equivalent circuitry. And a last time we already telling you, this is a transistor in DC. However, in AC, they replay by this module. This is the base, collector, and emitter. Okay? And when you have to say the difference, if I say IB, B will be lowercase letter. That's for AC. Okay? And from the collector go into the base, you get a current that IC. And you already know IC equal beta time IB. And from the base to the emitter, you don't have any more diode here. Okay? And now you can see a resistor. That's what they call an internal resistance from the base to the emitter. R prime E. And you can calculate the value by this formula. This is the formula. We not make it up. Okay? 25 millivolt divided to DC current IE. Okay, so basically, when you're looking into the transistor amplifier, you have to understand is it that the common emitter, common collector, or common base? That's a very general thing. They will be asking you. Even you don't have to go to too much detail. So this is a common emitter. Input applied to the base. output from the collector. Okay. And that's what we recognize common add meter. And what happened to common add meter? They already telling you here. Okay. Input, output will be 180 degrees or phase opposite. Okay. Input positive, output negative, and so on. And also C1 or C2, this is a DC blocking or AC coupling. What that means? They will allow only AC from the input go to the base, not DC. And also here, C2, they will be allowed only AC from collector go to the load, not the DC. That's what they call DC blocking or AC coupling. C3 will be the name at bypass capacitor. What C3 bypass? That means they bypass the resistor RE here. That means the current AC at the admitter, they not go down to RE. The thing is C3 short, so that's why they go to short to the route. So if you measure the AC voltage at admitter, you're supposed to get a 0. The thing that is short to the route. That's what everyone must be know in general. And this is a very good picture for the student. You can see this is input sideways. You see 0 here. That means only AC. However, at the base, you already calculate the DC by voltage divider. That's what you get 1.8 volt. And now you can get this sideways going to the same point. So that's why if you're looking on the scope, you will be seeing 1.8 volt and this is a sideways. If you want to measure the peak to peak of this sideways, your scope must be set to AC coupling. AC coupling will be trying to remove 1.8 volt. So that's why you can see this sideways. Otherwise, the sideways is very, very small compared to 1.8 volt. If you set it to DC, you cannot see this sideways. Okay? And at the output here, at this point, also you can get a DC calculation. That's what you get, VC 6.04 volt. And also you can get the sideways, the amplifier up here, the opposite. Okay? And how the signal will be look like. Same thing. If you want to measure this peak to peak, you must set your scope to AC coupling. Okay? When they go to the output here with the load, then you don't see any more DC. They start from 0. The thing is DC be blocking by C2. Okay? That's why I'm telling you. If you're looking at the output here, you see the signal look like that one. Guarantee something wrong with the capacitor C2. Okay? If you get any question, just go ahead and ask, okay? Now, again, this is draw for AC. Okay? And you can see the capacitor will be here. This capacitor will be this part right here. This is the bay. This is a collector. You get a IC current going to the bay. And also at the admitter, you get a current resistance R prime E. Okay, internal resistance. And now we need to connect outside to this transistor. Outside, they can get, first thing you can see 10 volt now, they will be routed. If they routed, and you can see this resistor RC here, connect to collector to the route. Also, you can see the output here, the load resistor. Also, they connect from route collector to the route. So this one and this one in parallel. So that's why you can see they draw right here. RC parallel with RL. Okay. And at the input here, you get R1 here, R2 here. R1 one side to the collector, the other side to 10 volt, they will be routed. So they're telling you R1, R2 will be in parallel. That's why they draw here. R1 connect to the bay, R2 connect to the bay, and both will be routed. So R1, R2 will be in parallel. Okay. And now we have to deal with what we call a G in and G out. G out means output impedance. That means at the output here, you're looking into the amplifier. You say which resistance in series or parallel. Okay. In this case, you see RC/RL in parallel. So that's why output impedance. Some textbook they're using RC but up lowercase. That means for the AC. Same thing with output impedance. Be calculated by RC parallel RL. That is easy to recognize. However, input impedance, another case. Input impedance, you guys get the input right here. You're looking into the amplifier. Try to see how many resistance in series or parallel. Try to combine it. Okay. First thing to see, R1 parallel R2. So you know R1 will be parallel R2. However, you still get a one resistance. You didn't see here. That's what we call a in base. What that mean? That means the resistance from the base to the route. That's what they call R in base. Okay? And R in base can be calculated. So now you can get R1 parallel R2 parallel R in base. Not this one, okay? This one internal, inside the transistor. So G in will be R1 parallel R2 parallel R in base. Example here. If we're looking into example here, you know that will be common net meter. Input 10 millivolt IMS apply here. Output will be from here. Okay. And you can see C1, C2 blocking, C3 bypass. If you don't have the bypass capacitor, then the gain of the amplifier will be lower. Okay? You want the gain higher, you better get bypass capacitor. And now this is a calculation. Basically, anyone must know. Even you not calculation, but you have to know the formula or the way we calculate it. First thing they want voltage here. Then you have the voltage divider. VCC times R2 divide R1 plus R2. After you get the voltage here, the difference at this point here will be 0.7. So you take VB minus 0.7, you get VE. If you get a VE, easy to calculate the IE. VE divide IE, you get IE. And after you get IE, then you can get the IB, then you can get the IC. Okay? So if you want to calculate the V collector here, you take VCC minus IC times RC. IC times RC, that means the voltage drop across RC. Okay? So this is basically you're supposed to do calculation. And now AC calculation are in base. That means the resistance from base to the ground, that's what they call R in base. And they will be equal beta times R prime E. Okay? And also they already got output resistance. That means you get output impedance will be RC parallel RL. And the voltage gain will be RC, that means Z out. Remember, C lower case, that means AC. Okay? Divide R prime E. If you want the output, you take a V input time with the gate. That's what we already done last time. Okay, on this one, do we need to, you guys already calculated or not? Anyone calculation? Maybe no, right? Maybe not. That means you not do anything. Let's see. So let's see. Four. Okay, so I think if you get a formula in the previous page right here, then you're able to do your calculation. I don't want to calculate it for you. Okay, we go to the next one. This is the common head meter. However, you see the difference. The difference will be they adding one more resistor. IE1, IE2. So they get the different name. They call it swamped amplifier. Okay? That's only the difference. So what I want you to do, quickly give me the DC calculation. You want to learn it, then you have to do it. Okay, I will be giving you the answer, but at least someone have to tell me what they get, what will be equal.
Zero 0.213 volts.
VB.
Okay. 1.75.
Exactly. VA. Right?
2.45. No, minus 1.07, 1.05.
Yeah, that's what I get, 1.05.
Mr. Pham, a real quick question.
Yeah,
On that one where you have the two resistors and you do VB and VE, the RE's got to be added together, right? For the DC side?
yeah, but the thing is you understand that to be right here. E right here,
Right.
and
But
it
when-
will be collector.
Right.
Okay, so
So
VB,
when you're figuring out the form, I mean, RE has got to be combined. In other words, 470 plus 470, and then you can get the current going through there.
exactly.
Okay, thank you. Thank you.
Then now I want to know IE.
$1.12 milliamp.
Exactly. IB. After you get IE, then you can get IB either. Easy one. And you can get the IC.
When IB would be microamp.
Oh, that microamp. Thank you, Sam. Okay, so we go up to that point. Now, give it to me, VC. What you get on VC?
4.736.
Okay, so
I got 4.74.
Yeah, round up 4.74.
VCA.
I got 2.636.
No,
Is that wrong?
fee is 1.05. Fee C is 4.74.
Maybe I hit the wrong button.
3.69.
Exactly.
Yeah, I hit the wrong button.
Price.
25 millivolts over IE.
$22.3.
Yeah.
I got 22.32 as well.
Yeah, that's okay. 22 ohm. Okay, so AC calculation. Go ahead and calculate the number B going down. In base, I already given to you the formula, everything already there. Okay, they will be 86.1. Did you get that? And number C, I in total. Okay, I given to you 7.53K. D, that means Z out. Okay, 4.27K. Okay, A mean the gain at the base. Okay. The formula already given to you. I given you the answer, 8.67. Let's see. Let's see, GLRC. BCD. D will be 4.27. Okay. AV at the base. AV at the base. 8.67.
What? I got 9.55.
If you substitute the value into that and calculate it, I get 8.67.
And Mr. Pham, and that's the gain at the base is right where the 8
Right here.
point, where the 8, yeah, right, yeah, right there.
VB. AB, sorry. A at the base. AB.
Right.
86.
Okay, F AV total. That means AV from here. Total. The thing that you say you can get a resistor right here. Output impedance of the generator. Okay. So basically, the gain, total gain, they cannot be only the gain at the base. Okay. Then basically, if you want to calculate it, you have to calculate by voltage divider. Okay, that's what they call here. Total here. AV base time with that resistor right here. Okay, resistor right here will be R in total divide RS plus R in total. So that you can get F will be 8.42. and G V out. Okay, 84.3. That's just for someone able to understand. Otherwise, we don't care. Go too much into the detail.
Mr. Pham,
Yeah,
I don't quite understand F. We're doing a voltage divider.
okay. You
for
don't
the-
understand voltage divider.
Right, the voltage divider between what two resistors?
Okay, now I can telling you right here will be, we already know, R in, right?
R in base.
R in base or R in total. We already telling you. Let's see. We already calculate the R in total. Okay. R in total will be include. That will be R in total. Okay.
Okay.
That means including what? R1 parallel, R2 parallel, R in base.
Okay.
Okay. So now you can get a resistor here. If I don't put it here, I put up here. So easy for you to see.
Okay.
Okay. So that will be RF.
Mm-hmm.
Okay. Right here, you get the voltage gain for the base.
Mm-hmm.
So if you want to calculate the voltage gain, including VF, then basically that one and that one just divider. Okay,
Mm-hmm.
that means you take that guy time R in base divide total. That means you get a total gain.
Mm.
If you don't have a this resistor, then R in base R total here the same. Okay. However, if you get a resistance here, then the total gain will be different. They will be take the voltage gain at the base time that one divide RF plus R in total.
Base.
Okay, so make sure you can get the answer. And if you want to go over, try to see how you can do it, that'd be fine.
Question, Mr. Flynn.
Yeah,
Just a technical question regarding the generator. Knowing the generator has the
output,
it has the 50 ohm resistor in it.
second.
So
What it
well,
is.
it has the 50 ohm resistor in it before the RS resistor.
No. On this one, they given you second ohm, not 50.
No, I understand that, but what I'm questioning, if that safety resistor fails and it puts a clip into the circuit before RS, the RS, the tolerance for that resistor will it adjust for any type of clipping if that 50 ohm resistor fails?
Why
So-
not do it?
So what I'm saying is if there's trying to be a measurement of voltage,
No, you don't talking about 50 ohm here. On this generator, they get 60 ohm output impedance, not 50. So don't worry about any 50.
Right, so in comparison to the safety resistor, how accurate would your AV be if that resistor started to go out of tolerance? If the RS 600 ohm resistor is possibly making up for the measurement. I mean, you'd have to know that the value of that 60 ohm resistor is failing, so you'd have to make up for the calculation with the 600 ohm resistor in order to get an accurate
Now,
AV total.
now you have to calculate based on what they given to you. I said, don't worry about 50 ohm. Now, if they give this one is 50, that'd be fine. However, they given you a different output impedance, 600. Then you're working with 600. You don't care the accuracy or not. But the thing is that generator given you 600 ohm, then you're working on 600 ohm. If they given you 50 ohm, you're working on 50 ohm.
Thank you.
Yeah. Okay. The thing I want to get through, okay, as much as we can. Otherwise, we're very close to the end of this semester. The next one, CC amplifier. And they get another name, 8-meter follower. For this CC amplifier, collector at AC ground. Remember, common 8-meter. So in AC, 8-meter will be grounded. Common collector at the AC, 8-meter will be grounded. Common base in the AC, base will be grounded. That is a very, very basic. Okay? Common collector, they get another name, 8-meter follower. Stable voltage. And now, this is the thing you need to know. They will be get a high input impedance. Okay? If they want the amplifier with a high input impedance, they better using common collector and low distortion. And this is how the circuitry will be look like. This is VCC connect directly to the collector. Divider here. Okay. This capacitor DC blocking. This capacitor also DC blocking. Okay. So what they said, input applied to the base, output from 8-meter. C1, C2, DC blocking. Okay. Input, output will be in phase. Both go up or both going down in phase. Okay. The question is, how come they said this is also named follower, 8-meter follower? How come? 8-meter follower. How come they get that name?
Output is the same as input.
The same at 8-meter. Output, V out and V at the 8-meter will be the same. So that's why they say 8-meter follower. That means the output same as the admitter. So either voltage here or voltage here will be the same in AC. The thing capacitor will be shorted. Okay, that will be explained to you. How come they get another name? Admitter follower. Our common collectors will be the same. Okay, AC. R in base. R in base, that means you're looking into the base. You're looking here. And what they said, you can get R prime E. Okay. Plus RE times a beta. Okay. And how come they said I in base equivalent to beta times RE here? Remember, RE here is not that one. Okay? Why it's not? You can see this is a REDC. However, this one REAC. Now, REAC, okay? Basically, you're looking here, okay? You're looking from the output here. And basically, you can get RL, okay? So RL will be parallel with big E, okay? That means the output impedance of the common collector. R small e, output impedance, equal RE parallel with RL, okay? So if you want to calculate the R in base, you get a beta times R prime E plus on that one. However, R prime E is too small compared to R big small e. So that's why they ignore R prime E. Okay, and R in total. So basically, R in total, you can get how many? This one parallel to this one, and also parallel with R in base. So that's why in here, R1 parallel R2 parallel with R in base. Okay. And also they given you the gain, voltage gain equal R small e divide R prime E plus R big E. And if you calculate the V out, AV times VE. Okay, go ahead and calculate it for me. We try to finish common collector, common base today to finish that bipolar transistor amplifier. I can give you the answer, but you have to do the calculation at least for me. Okay. Let's see. You calculate for me number F. Or if you don't have it, the other one you cannot. Go ahead and calculate as much as you can. Let's see, I can give it to you VB equal 5 volt, correct? VA 4.3. IA 4.3 milliamp. VC 10 volt. VCA 5.7. RYA 5.8. And only now you calculate for me number G, RE, or GL, output impedance. Output impedance will be RE, big E parallel RL. How many ohm? Did you get that 500 ohm?
Yes.
So if you're doing all of the calculation, and you can see the gain for this amplifier, they will be equal 1 or less. That means they have no more gain. Whatever input coming in, almost the output coming out, are a little less than the input. So they're telling you common collector, the gain equal 1 or less. And the question is, how come we need this amplifier?
The high impedance input.
Exactly. The thing is they get a high input impedance. What happened for the amplifier with the low input impedance and the high input impedance? For the low input impedance amplifier, what happened? Now, this is a low input impedance. What happened? This amplify 1, amplify 2. Who understand? For this is a low input impedance. And what happened?
Is it the output of amplifier 1? The output would be affected by the input resistance.
Exactly. When you get a low input impedance, they will be loaded down. Okay? That means the output may be 10 volts. However, you get a low input impedance from the next one. They will be pulling the 10 volt going down. That's what the low input impedance. However, when they get a high input impedance, okay, if you get a high input impedance, high R, so if you get a 10 volt here, then 10 volts still there, okay? They cannot loading down. That's why you need this common collector. If you don't want the output of your previous amplifier be loading down, okay? Even the gain will be the same. However, they get the benefit for the high input impedance. So they did not loading down any signal coming. That is require your understanding, okay? For detailed calculation, you not really care. The thing is basically interview job, even that they not asking you too much detail. The thing is the people interview sometimes they still forget everything. They just understand in general. Okay, so what I want you to know, when you're looking into the circuitry, you know that common collector. That's the first thing. Second thing, if they want to understand why they get the admitter follower amplifier, that is the thing, the output and the admitter voltage will be the same. And the simple thing is, if you want to calculate the output impedance, and you can say R big E parallel RL, easy to memorize. Okay? And the gain, voltage gain for the common collector maximum equal 1. Input output are not the same and will be in phase. The last one, the input impedance for the common collector will be high. Okay, that means they're not loading any signal coming in.
Mr. Pham, one real quick question.
Yeah,
On that schematic there, is that typical for the common collector? The collector side will not have a resistor. Is that typical?
yeah, typical.
Okay.
So sometimes if they don't have a load, okay, if they don't have a load resistance here, then output impedance will be this guy,
Mhm.
not parallel.
But what about up into the collector area? They never have a resistor there?
There must be no resistance.
Okay, all right, thank you. Thank
Yeah,
you.
so that's why they get common collector. Okay, solution that for your guy calculated. Common base. Now you get better. Common base, AC route. Input right, the admitter and output is taken from the collector. That means the input applied to the admitter and output from collector. No current gain, but has a high voltage gain. Now they get a low input impedance, high output impedance, and will be high frequency application. If they're using high frequency, then they can using common base. This is a common base. You can say input here, apply to admitter, and output here from collector. They will be in phase, and the voltage gain will be big. So that's why you can see they will be bigger. The thing is, when you understand that thing, you're working on the common, you're working on the transistor amplifier level. That helps you a lot. Okay. And this resistance here, C2, what the name on C2?
DC blocking.
DC blocking, AC coupling. So that's why For calculate the DC voltage here, you still get the voltage divider to get the voltage. The thing is this guy output. Okay. However, when you apply AC, this will be shorted. They will be connected collector to the ground. So that's why they get a common collector. Okay. And if you calculate the gain, they will be RC divided to R prime E parallel R big E. Okay. Input resistance. That means you're looking in here. Then you can get R prime E. That means you can get resistance here. Parallel with R big E. And now put in resistance RC parallel RL. Okay. C1, C2, DC blockage. Only one we go too much detail common meter. Okay. And this example here, if you're looking on AC module, this is a collector right here. This is the base. Okay, and this is the meter right here. Okay, so you can get the RL here and RE here. Okay, so basically you get a route right here. So that will be telling you, you get, let's see, RC parallel with RL. Now, RC parallel with RL. Okay, the thing is right here, you can see that this guy. Okay, and this guy parallel, exactly the same common meter. Okay, and also let's see what you said. Input resistance. Input resistance. That means if you're looking from here into the base, into the meter, sorry. Then you can see from meter go to the ground, you get R prime E. In the meter go to the ground, you get R big E. So that's why input impedance will be R prime E parallel R big E. Okay. Okay, let's see, that one K, 2.2, 10K. Okay, what the beta? Beta here. $250. Okay, if you don't have it, then make sure you get beta. $250. Okay, what I want you to do, go ahead and do calculate this guy. They say at least you have to do the calculation. We already given you everything, formula, okay? Okay, what will be? What you get?
1.764.
Basically, you can get 10 volt times 12K. Divide 12K plus 5, 56K.
$1.764.
Exactly. 1 point. Okay. And the next one, easy one. Right? 1.06. And the current. 1K, that's telling you 1.06. Okay, telling me VC, okay? You need to get a little more calculation. You have to calculate the BIC. But what I want VC. Who get the VC? Nobody get the VC calculation yet.
The 7.67,
Can you repeat again?
7.67.
Exactly. Is it Adam?
Sorry,
What's your name?
Michael
Michael.
Yuklu.
Okay. Is it Michael Zulu?
Yeah. Yeah.
Oh, okay. The thing is that what happened to me, okay? If you think you apply the job, they asking for your certificate. I can give you certificate right away. I don't care what. The thing is basically you have to understand. If I know how you're doing in the program, so when you apply for technician job, I can guarantee company will be feedback into this program. You're asking me evaluate for job. Okay, so I need to know who will be really understand that everything will be good. However, otherwise, what can I say? I already did a lot helping for my student. So we in Zoom, so you have to talk it, okay? So I know who will be good. Otherwise, it's hard for me to recognize. Okay, next one, VCA easy. I can give it to you. VCA will be 6.62. R prime E, 23.58. RE, 2304. O. RC, output impedance, 1.8. Voltage gain equal 76.3. So if you see any different answer with you, let me know. The thing in liquid meeting, we can go to the decibel and also differential amplifier. Okay, any question? If it's not, that one we already done. Darlington connection. And that will be example for the DB. Okay, we will be talking after we get through the lecture for the decibel. Now, this one, multi-stage amplifier. That means you can get common net meter, common bay, common collector. And now they combine. If you look in here, first Q1, what's the name for the amplifier?
Common emitter.
Exactly, common net meter. How about Q2?
Same common emitter.
Common net meter. Correct. Correct. Okay, now output of the Q1 connect to the input of the Q2. They using the capacitor here. So that will be coupling. Okay? That telling you what? That means you get the AC right here and DC. However, when they go to the bay of the Q2, you don't have any DC from Q1, but you get only AC on the Q1 go to Q2. Okay, that will be AC coupling. So if you get a sine wave in V in here, and the output here also sine wave, but they have to be opposite direction. And the same thing when they go to Q2, and the output will be opposite to the bay of Q2. Okay, so that will be telling you input at V in and output of V out will be in phase. That's what you're working on the left volt. They call AC coupling. Okay, and if I'm looking here, you get C2, C4, just a bypass capacitor. Okay, and basically for that one, for multi-stage of the circuitry, okay, given they want to solve for VG1, okay, VE1, IE1. That means for Q1. And everything here, I already given to you the calculation solution. Then you can look into that, okay? We don't go too much detail in here.
Mr. Pham, what is VG1? Should that be VB1?
Which one, VG1?
Uh-huh.
That means the gate VG of the Q1.
The gate.
That means here.
Oh, okay. Shouldn't that be B then?
VG.
I mean VB, B for base.
Supposed to be VB.
Right. Okay.
However, in here they're using VG. VG2
Okay.
right here.
Okay.
That's a summary. However, I want to see what else. Okay, now I can this one. If I connect this way, take it out. So this is also the multi-star amplifier. However, they're not AC coupling. What they said, whoever working on the level on the bipolar and amplifier, you already working through that. What is configuration for this connection? You cannot AC coupling. Who knows? What the name? Between Q1 and Q2, I remove C3, just a wire. You don't have a C3.
Isn't that a direct coupling?
Exactly, direct coupling. You have to chat to me your name, okay? Please. I want to know. The thing is, I understand your voice for a couple of things, but I don't know your name. Okay? Direct coupling. That means whatever at the collector of a Q1 will go directly to input of the Q2 without any capacitor. If you're working on the left phone, you have to working on both. Why they working on AC coupling? And another one will be direct coupling.
Why wouldn't that be considered a direct node instead of a coupling?
What?
Well, coupling is referencing a component, but if you don't have the component, it's just common node circuits. Why wouldn't they call it just a direct?
Direct, that means whatever from collector of Q1 go directly to input of Q2. They don't limit the DC.
So it wouldn't technically be called a direct node then?
Can you say again?
Would it be also considered a direct node instead of a coupling because you have no component?
Yeah, no capacitor here. The thing is you're working on level for a long time, okay? You don't want to know what's going on. However, if the people currently working on bipolar transistor amplifier, then you can see the difference between AC coupling or direct coupling. Okay, let's see. One student typing to me, the name is Sophia. Is that right?
Yes, Sophia
Okay,
with the
thank
row.
you. Thank you.
Thank
I
you.
knew you. Okay. I can recognize it now. Okay, thank you very much. So that's why I said you have to be a little more active in the program. Otherwise, when you apply for the job, they will be get a reference from the school. What can I say? If I don't know how you do it, what you do it. Okay. So any question, anything else? The thing is that just a summarize, okay? Summarize everything for you. We learning at the beginning, okay? So, any question, anything else? Remember, for this month, lab will be tomorrow. Okay? Tuesday, Wednesday, Thursday. Friday will be Tech 2 lecture. Okay? So, only thing is, if I recognize you understand it, either electronic and also in textual digital, then for some reason, you need a certificate for your company, then we can try to help you. You understand my sale get the design, given our certificate. City don't care. If I sign, they sign it. If I'm not signing, so you can stay forever. Okay, so finally, any question to me?
Can me and Sam go over the D labs?
What about the lab?
Oh, I just need him to go over my P-Spice schematic.
That will be on Friday.
But I don't want to wait till Friday though.
Okay, so
Right.
now you get a question about that. You want to share that?
Yeah.
Okay, let me stop that guy.
Thank you.
Yeah, I can help you out.
All right, I'll share now.
Yeah, say it and any question. Confusing. Bring it up. We'll help you out.
Okay, so this is the circuit I have, right? This is for the first D lab, right? So for this guy, this is what are these? These are the inputs, right? So are they off page? Is that what that is? And then you just
That's
label.
global. That's a global, right?
Global. Let me see.
No, you get the right one, but I asking you, is it that the name is global?
Like the part is called global. You can type in the part name on top there. So part name, type it there, global.
Oh, I didn't use. I used off page. Oops. So okay, so this is supposed to be global,
Yeah.
and then for the output, is it the same
And
thing?
the input. That's just
Yeah.
a connector.
Mm-hmm.
Yeah, the part we call global. Those are.
Oh, okay. So I used this. I used the off page.
And then put the label on there. Yes.
Okay.
And
so
the
they're
other
both-
thing that you're missing on there is the include file. So you can type in include on top and.
Okay, so how this works is you build the circuit and then because I started the Tech 2 in the summer, I skipped over the spring. So
yeah.
So once I have the circuit,
yeah, you can go watch the video. Mr. Pham went over this on I think he went over on Tuesday.
I searched through the videos. It's just I mean I
Okay,
searched through
now,
all the videos.
okay, you draw this circuitry, right? Okay, now you done for drawing this circuitry. You need one file. That's what they call include. Go to the get part, get the include. Go to draw, get the include.
So include
Right.
the include
Yeah, just include. Take it out. Play it.
Right click to exit the mode.
Okay, now that is the one. You want the input to be.
go ahead. First thing, right click first to get out of that page. Okay, now we're in the page. Okay, go ahead and double click on that include. Okay, and here we put the label on. So to choose the file name.
Yeah, but what file
No,
is
no,
that?
you want to choose the one, highlight the file name first.
Oh, okay, file name.
Okay, and then you put the file there. Now you should have like an ETT folder inside your C drive, right? Did you create a ETT folder in your C drive?
But I didn't create any.
You must
Any-
be in Greek.
Yeah,
Okay?
so
Type
yeah.
in C.
So create one, yeah, go to your C drive and just create a folder called ETT.
Okay, I think I do have it, but
Okay, so you're gonna put it there. So you're gonna put name, okay. Okay, so if there is an ETT in your, is that in your C drive or is that in the E drive? Or G? I do not know. Okay, it's in your C drive. Okay. So here, yeah, you're gonna do the so you're gonna be at your file name, you're gonna put, okay, go back to your schematic. Go ahead and close that folder. Okay, so you put C : backslash. Just one backslash would be fine. ETT. And then so you want to call, and then backslash. This would be DLab1 SP 2022.
Dot.
Just go put, go ahead.
DLab.sp.
No, just go put DLab01 SP 2022. So that way you know that this lab is for spring of 2022.
You make sure they get a dot, right?
Now you put a dot at the end,
Oh.
dot STM.
STM.
Yes,
And
so,
that's for
so-
this.
so
What
you
that
want to put, yes, okay, and then
Like that?
click save attribute. Okay, now click OK. Okay, now you're gonna be, that is your file that you're gonna put your input information or your timing for your whatever the if you look at your truth table. Okay, so you double click on that CETT DLab SP 2022. Double click on it. Okay, here it said,
okay.
do you want to create one? Yes, you want to
Uh-huh.
create one.
Yeah.
Okay. And then you follow from the include that that Mr. Pham gave you on the, it's on the class in
On the
your,
web.
yeah, on your, yeah, on the web, on the handout for the include file. You want to follow, you use that same
Where is it on the
website, on the handout.
Let's see.
Hey, Sam, while he's doing that, didn't at the beginning, he tell you guys for his global, he put in the wrong thing, so he needs to change it?
The one thing at a time, please.
So where
So
is that? In the handouts?
Right, no, it should be here. There should be the spring. Remember, you did the include file already. Right there, it said include file. So
This
you
one?
want to use the same, yeah, you're going to use that same structure. So open up that and you look at it, right? So the first thing you want to start is UH1, and then you got space STIM 1,1 space, and then you got $G_D power. You want us to write that information in.
Oh, okay. Oh, okay. I don't
And
think
that would represent, and then your plus, and then you start your first input would be PA01. And then you have to look at your according to your truth table, according to your DLab1, okay? And you fill in the rest of the information that is there for your DLab1. So
I kind of copied it off the video, so.
Okay.
Other thing, you go into website. I already get the one for you.
Yeah, I think Mr. Pham has one available on the handout in the
On
website.
the handout. Open that.
He's already carried an STM file there already.
Go to TechJoe. Where the
Oh, okay. Oh, see, okay, makes
So
sense.
you can copy and paste that onto
Okay,
your.
makes sense. Okay, and then you copy that onto the
Paste
STM
into
file,
your,
then you
Yeah, copy and paste it there.
then you run the simulation, then you okay, got you.
Okay.
Cool.
and make
Thank you,
sure,
sir. Thank you guys. Thank
yeah,
you.
and make sure when you changing, you want to say, don't say add, okay? Just save it,
Save. Just
Okay.
save.
yeah,
Okay, got it. Thank you guys.
yeah. The thing is, the process to do the lab will be repeated on Friday. You try to get done for your Excel and your program. Upload it so Sam will be take that out. If it pass, they let you know. Pass, you build the circuitry. And you have to make sure you run your software with your hardware they working. And you need the lab instructor to verify for the credit. Okay?
Okay. Thank you. Thank you.
Okay. So good night, everyone.
Okay, good night.
All right.
Good night.
Good night.
Right.